Question number 24. IIT Kanpur sample paper 2023. Summation n is equal to 1 to infinity n square lambda to the power n by n factorial. So one of the n cancels n factorial, it is n minus 1 factorial. So this can be written as lambda summation n is equal to 1 to infinity n into lambda to the power n minus 1 by n minus 1 factorial. So there is a side angle to it here. Let me just share. E to the power of lambda is 1 plus lambda square by 2 factorial lambda cube by 3 factorial dot dot dot. If I differentiating this entire thing, this remains e to the power lambda 1 plus 2 lambda by 2 factorial 3 lambda by 3 factorial lambda square, sorry, 4 lambda cube by 4 factorial. This is what is happening. Now, this can be written easily as lambda into, this is lambda to the power 0 by 0 factorial, 2 lambda by 1 factorial, 3 lambda square by 2 factorial, lambda common, 1 plus, I am writing this as lambda plus 2 lambda square by 2 factorial plus 3 lambda cube by 3 factorial plus, so this was 2 lambda by 1 factorial, I wrote it as lambda, so I have one more lambda, 3 lambda square by 2 factorial, I wrote as 2 lambda square by 2 factorial, so I have another lambda square by 2 factorial here. 4 lambda cube, I'm writing it as 3 lambda cube, so plus lambda cube by 3 factorial. These are all additional. Okay, so this is what I can write. Okay, so this can be written easily as, this first part is basically e to the power of lambda, right? E to the power of lambda. Sorry, there is a 1 plus lambda, I have to take it as common. One plus lambda, if I take common, 1 plus, this is what I will get. Plus, this part is nothing but e to the power lambda minus 1. Okay, so you can do this in this way. It is a little complicated in terms of the summations. What you need to do is as follows, that is written here.